Great. And kick things off, I think a few more folks might be joining us, but we know that you all probably have a busy morning. So we'll go ahead and get started with our tag meeting for the Fauntleroy Ferry Terminal Replacement Project. It's good to see many of you, and thanks again for being here this morning. Again, my name is Laura Miller, and I will be helping facilitate today's meeting. We encourage those of you listening in to submit comments to our project inbox at any time. I will go ahead and drop that email into the chat. And just a reminder that we are recording the meeting today, and we'll post it on our project website for anyone who can't attend live. We will go ahead and share our agenda for today. So we're going to continue our conversation on key project elements to inform our level 3 screening with the focus on the results of the Good to Go and Advanced Ticketing study. Dave will also share with us an update on the Fauntleroy Southway Southwest intersection improvements. And then we'll follow our similar structure. We'll have plenty of time for conversation, discussion after the presentation. And with that, Hadley will remind us of where we're at with the project timeline.
Thanks, Laura. So we've all seen this before, so I won't go into too much detail, but as a reminder, we're in the level 3 screening phase of the planning and environmental linkages study. We're hoping to wrap that up this year with the selection of a single alternative to move forward into further environmental review, into the NEPA-SEPA process, and then into design construction in the 27-29 biennium. This year we'll be at the point where we've selected a single alternative, and then early next year we'll be wrapping up the Pell process with the Pell study report, documenting all the work we've been doing and documenting Pell to carry that work into the NEPA and SEPA environmental review process. And then the next slide just gives another view of the process we've all been in over the last several years. For those of you who haven't been at every meeting or working as closely with this project, we started out with a real broad range of potential alternatives, including moving the terminal to other locations or other more out-of-the-box solutions, and have narrowed down the range of alternatives to different dock sizes and configurations at the existing location in Fauntleroy. And that's what we're working through right now, is refining those alternatives, and we'll be screening those according to the screening criteria that we discussed earlier this year, criteria based on the project's purpose and need, to select a single alternative to advance into the next phase of the project. And then this slide is just our roadmap, where we've been going, all the meeting topics we've covered so far. The last several meetings have focused on the environmental analysis and traffic studies. Today, we're going to focus, as Laura mentioned, on the idea of Good to Go and advanced ticketing as technology solutions that could help achieve operational efficiency at the terminal. And then the next meeting will cover cost and construction phasing and approach, and what service could look like during construction. And then we'll be moving into the level 3 screening process and asking for feedback on the alternatives that come out of the screening process for further study. So with that, it's a quick high-level overview of where we're at and where we're going. Are there any questions on that before we move on? What our process is, what our sort of goals, and what's coming this year? Okay, with that, I think I'll turn it over to Dave to get us started to the main subject of the meeting.
Yeah, thanks, Hadley. Again, David Sowers, Director of Terminal Engineering for Washington State Ferries. Before I hand it off to our consultant who's been working so diligently on this Good to Go effort, I just kind of want to give you a little bit of an overview of it. I know last month we shared with you the traffic analysis work that had gone on, and that is a big component that feeds into the analysis that we've done here. So we're going to be talking about that today. This is actually took a little longer than we'd hoped. The process of figuring this out, the technology is fairly complex, but we've been working hard talking about this with internally with our operations folks, with our information technology folks, policy staff, both internally and in Olympia, and just trying to understand the feasibility of implementing Good to Go and as well as implementing a full version of Wave to Go at Fauntleroy. So we sent out a report about a week ago. If you haven't had a chance to look at that's okay. Matt's going to walk us through his analysis and talk about what it means to the project. As you're aware, one of our number one strategies in this work is to try to improve terminal operations. And the idea was floated to look at Good to Go as one way to streamline our operations through the toll booths. The community has been in the past very interested in this. And so there's other operational strategies we're also looking at, but this is the one that we want to talk about here today. Our goals for this study are to improve operational efficiency, determine the feasibility of Good to Go at this terminal, and also looking in the longer view here, could it be applied at other terminals? We want to identify any policy changes and look too at the economic justice priorities that are necessary and that we need to be mindful of as we implement something like this. And then we're doing this all around evaluating the viability of maintaining the current dock size. So that's how the Good to Go is being considered here. So before I hand it off to Matt, what we really want to do is kind of give you the key takeaways from the work that was done and kind of what we want to move into the level 3 screening. Alternative A2. We will continue to advance that option 2 within A2. We found that the Good to Go approach could improve our time in processing incoming traffic about 1.5 minutes or so, about 10% of the dwell time, and while retaining the current fare structure. And the cost of that is certainly lower than some of the other options for Good to Go. But it fits also within our project schedule. And then the other alternative, A3, that we're going to advance into the level 3 screening is a full implementation of Wave to Go, which sort of makes that a universal process that would be used rather than just as it's used now, kind of intermittent. And some people use it and some don't. And that implementing that universally would also save us about 1.5 minutes. So those are kind of the two alternative options that we want to take into the level 3 screening. I will say that, and to kind of cut to the punchline, there were other options within the Good to Go implementation, but those ran into both fare issues and policy issues, and Matt will talk about that in a minute. So with that, I'm going to turn it over to Matt Ringstad. And Matt, can you introduce yourself and share with us Good to Go?
Yep, you bet. Hi, everybody. My name is Matt Ringstad. I work for Jacobs Engineering, and I've been the supporting program manager for the toll division for the last 10 years, and I've been working with the toll division for the past 15 years. So I have a lot of experience with the, just the general ins and outs of how we deploy Good to Go in various highway facilities, and then looking at this particular unique application, I think was exciting for us. So I just kind of want to go over the general overview of the paper, cover like what we assumed, a lot of different elements in terms of what we analyzed, and then kind of wrap it back up to what David started with in terms of the recommendations. So realistically, just to let everybody know, this study builds on the WSF's traffic analysis that we previously looked at a month or two ago. And it helps evaluate the operational efficiency for all level 3 alternatives. So we looked at all the dock sizes across the board that were in the level 3 screening. And then this analysis uses the same model, that we used to determine the baseline levels. And then we build on that by inserting a couple new inputs that the model can utilize to simulate what we feel would be the impacts of each one of the Good to Go options, as well as the Wave to Go options. So the model evaluates 4 Good to Go options, of which we'll talk about in a minute, and then 1 Wave to Go ticketing option, and against all the dock sizes, as I mentioned. And then in terms of the baseline assumptions, that model, I just want to remind everybody, that model uses the ridership projections from the WSF's 2040 long range plan, as well as the 3-boat schedule. So that is some of the foundation assumptions that the model has built around. And then we came in and evaluated the good to go options on top of that. All right, this is just a quick reminder of Good to Go. I'm sure many of you are familiar with it. It's essentially an account-based payment system. So you sign up and you tie your pass that you have on your car to that account. You can tie a credit card to it as well, and then the billing system takes a hold with Good to Go, and we use it for fast payment processing for everyone on the toll facilities. The toll facilities, I think everybody's familiar with, everything from Tacoma Narrows Bridge all the way to the latest SR99 tunnel. And these are the typical applications that Good to Go has dealt with. So this is going to be a unique analysis in terms of trying to apply the Good to Go technology to a terminal-specific destination for ferries. All right, I'm going to start with the first option. That is the Wave to Go option. So I think everyone's probably familiar with Wave to Go, what it offers now. I think it has a great beginnings. I think everyone knows that it has some shortcomings. That being said, there is already plans to modernize and enhance Wave to Go. There's already funding in place to begin this process. And some of those things that are really going to help the usability of how customers can interact with the product. And that's going to be like with its own app, for instance, and the store that everyone has to click online and go to be able to reload or buy or purchase a product. That will be smoothed out and incorporated into the app. You can get multi-ride passes through the app. There's a lot of things that can be just smoothed out within the process. And that's important. So I want just to remind everybody that's important. It's also this implementation or enhancement of Wave to Go is system wide. So there is a value because this is going to affect Fauntleroy, but it affects every other terminal exactly the same way. So there's a consistency in terms of the deployment of this modernization of Wave to Go. Specifically for Wave to Go, we have determined that there's about 50 to 60% of the Triangle Route customers already purchased tickets in advance. But many customers kind of get bogged down in the transaction processing process, even if they use Wave to Go, because they're driving up to the toll booth and reloading their e-purse or their multi-ride tickets at the booth instead of doing it beforehand. Mostly, I think, because of some of the shortcomings that I mentioned before. This slows the process down. It's not everybody, but all you need is one or two in any singular loading, and that 30-second transaction processing, 15-second transaction processing that it could have been balloons to 1 or 2 minutes to get through that process. It then becomes parallel to cash payments, which are the slowest toll booth processing time. So I think especially during the peak sailings, increasing the use of Wave to Go, Good to Go, any type of electronic transaction processing is going to save time when it comes to loading the ferries. I just want to also note with Wave to Go, we assumed in the paper that we would have Wave to Go intact and provided to the customer along with Good to Go. So we separated them and not fully integrated them through options 3. Options 4, when we get to that, I'll explain it to you in the next slide. Option 4 is what everybody knows. That is the all electronic version, without stopping. And at that level of complexity, you are no longer able to provide Wave to Go. So options 1 through 3 still offer Wave to Go in parallel with Good to Go. All right, the Good to Go options. Very exciting, I know. So what we try to do is go from option 1 to option 4. Option 1 being the least complex, option 4 being the full all electronic, most complex. The sliding scale works in terms of how long they take to implement, the shortest to the longest, the least expensive to the most expensive. So everything graduates up. But the idea of it is that you don't have to start with the all electronic option to be able to apply it to Wave to Go. And in fact, or to WSF, In fact, it might actually make more sense to do a lesser complex integration option, because it allows for good to go to get its foot in the door, so to speak, and allow people to get used to it, and then we could build the complexity from there if the technology allows. So option one, this is the starter option, really basic. I'm going to quickly go through these, and we can cover any follow-up questions later. But the starter option is effectively just the same thing. You have a toll booth attendant. All the same processes by that toll booth attendant are the same. You basically at the end, you're able to ask the customer, would you like to use your good to go count? Because the reader can read the pass, knows you're a good to go account holder, and then you could bill all the charges to your good to go account. Just a simple yes, no kind of thing, but it does not do anything else in terms of leveraging any of the technology that good to go offers. Option two is we start leveraging it a little bit further. It's a semi-automated option. The booth attendant is still there. However, the difference is that it's leveraging the cameras, the readers in conjunction to packaging up a price. And all the booth attendant needs to do is identify vehicle passengers, add those to the price, and then again, it falls back to option one. Would you like to use your good to go option? They say yes, it's already done, and they move through onto the dock. So in that one, you're using the cameras to actually classify the cars that are driving up, or vehicles that are driving up, and establish what kind of car it is and how long it is, so it can get the right driver vehicle fare applied, and then we just add the vehicle passengers as appropriate. Option three, this is probably one that everyone's more familiar with in terms of everyday life. It's more of a parking garage ideology, where you have a dedicated lane. It has a parking arm. There's no attendant at that particular toll booth, and effectively the technology would read the good to go pass. It would assess a price, and it would leverage additional technology such as occupancy detection to apply costs to that. It packages the fare and runs the parking. This could also with Wave to Go. So if the app for Wave to Go, someone has a multi-ride ticket, they could just scan it on the QR code on the kiosk on the side of the dedicated lane, and they would move through as well. So there's definitely some options there in terms of how that sets up. The other side of it is that there would be a traditional toll booth also available. So you have the good to go, Wave to Go folks that would be routed off, and then you could have traditional payments going to the attended booth. So that's option three. And then option four being all electronic tolling technology. Customer drives through onto the dock without stopping to pay. You know, I think everybody's pretty familiar with that. It fully leverages all the technology. However, you know, both options 3 and 4, because they are not attended, do require occupancy detection, and therefore do start altering or impacting fare structure because there's limitations of occupancy detection of what we can do. So that then infringes on fares, and then of which in turn starts infringing on policies that we will establish here next. All right, so how does this apply to the project? I think screening criteria was the first and foremost thing that we looked at. There is a large amount of screening criteria for the Pell phase of the Fauntleroy project. Of those, we but figured that there was 4 key screening criteria that were applicable. And these are the following 4 that we identified: with operational efficiency. That's probably the most obvious one, you know, and then followed by the project cost. How much is this going to take? And then we also have the current schedule. What does this do to the current schedule, and how long would it take to implement such technology? And then finally, policy risk. So as we talked about, there's based on existing policies. Does any of these options present a risk or a substantial project delay? So we'll talk about how, and the paper goes into detail on how it affects those 4 categories. All right, study metrics. This is based on the traffic analysis, right? So we really tried to use these 5 key metrics to flow through the paper. We really were able to get some really good data out of the model based on our inputs. And I'll just start out with one that's not technically on this list, but it is just kind of the overarching key metric that we received, and that's the fact that we established the model baseline. So that was done in the traffic analysis. And then as you move through and apply the good to go options and the wave to go options, you start to see time savings. And we established a model. The model time savings is effectively the baseline minus what we're getting in total in terms of total unload and load time when it comes to the calculated dwell. And then we took that model dwell, and then we compare it to some of the schedules that were in the 3-boat schedule dwell times. So we took the baseline, we knew what was scheduled, and then we said, oh, okay, well now the dwell times could be this at best for each one of the options. What does that do to us meeting the schedule? And so that looks a little bit further in terms of its effect on on-time performance. And then the next is queuing. Queuing, I think everybody's familiar with that term. It is a long queue length that runs up Fauntleroy Way. We could evaluate how long that peak length is. And then we could also measure, as a function of how effective the processing is, we could also measure the rate of reduction. So how that peak queue length reduces over time. So it's the rate that it does. How fast does the vehicle queue decrease over time? So those are good performance measurements that come from that time savings that I mentioned above. And then as we talked about it, we have some specific focus on the implementation costs. We have a good idea of how long it takes good to go to be implemented. We've been doing this against those facilities that I mentioned. We're gearing up for new facilities. So we have a pretty decent idea of all the vendors, the contracting that's necessary, the oversight. We've also gone into, community engagement, any policy and fair change processes that need to be supported, and then operations and maintenance, and even to the customer service center support. So that all of these things are entangled in terms of how we price or estimated what we think it would cost to apply it to Fauntleroy, and then specifically how long it would take. And then we go into customer experience. I think that's pretty straightforward as well. We looked at features and benefits that affect the customer experience. So it's not just limited to what are the fare changes and what do they mean, on-time departures, less time unloading and loading, all those things benefit. Is there less backup on Fauntleroy? Those are all good things that the customer could experience through Good to Go and Wave to Go. I think the tangential component of customer experience is this better overall? Do they feel like it's an easier use of the technology and getting them onto the boat quicker? And then also just ancillary things where you have, the Good to Go gives you the ability to, because it's an account-based system, look back and you could see all your transactions over since you started the account effectively, and you can see how much you use the ferry and how much you use the highways and back and forth. So you do have a historical a context to how you maneuver in your everyday. So policy and fares is the final one. Based on the available occupancy detection technology within the project timeline, WSF developed sample fare tables. So we looked at all the fare tables and we tried to say, okay, if we can't assess specific discounts, that are required because WSF is federally funded. If we can't do that for the vehicle passenger, what can we do? So we came up with a couple ideas that work within the occupancy detection technology right now. And, what we found is you really can't assess things like discounts for age, disability, tribal agreements. You can't do those things within the occupancy detection by itself. So you can do it for the driver because they're the owner of the Good to Go account. I can go through and change functionality and develop functionality that can allow for these discounts for the driver. You just can't apply those to the vehicle passenger. So you only have a couple options in terms of that. And so the paper goes into that fork in the road. And then what it also applies is really the effort to adhere to the guiding principles and policies that Ferry's abides by, and that is really to avoid disproportionate impacts to marginalized communities that utilize this service on a critical level. They can't go anywhere. They don't have alternative routes, all those kind of things. So that's kind of where the policy and fares come in on the study metrics. And then we're going to get into the results. So I think the key thing in breaking down this chart, it's on the y-axis, you can see it's minutes. On the x-axis, you can see that it's the alternatives, the dock sizes. And so they're grouped by dock sizes, and you can see how Good to Go and Wave to Go perform against that, against the baseline, which is the dark green bar on the left of each one of the alternatives. And then what we could do is distill a little bit more information. But I want to highlight one quick thing is in terms of the unload and load times, that dwell time that we've been talking about. It's made up of pedestrian, bicycle unload and load times, as well as the vehicle unload times. So all three of those metrics, after running the model over and over again, they start averaging out and they become relatively fixed units. And so the only thing that this particular study can affect is the loading time, which makes sense, right? So we're affecting just that component of what makes up the dwell time. And then overall, just kind of getting to the point here, you can kind of see that the A2, which harnesses the entire umbrella of all the Good to Go options, ranges from effectively a minute worth of savings in option 1, all the way down to 3 minutes of savings with the all electronic version, which makes sense. You're not stopping, you're going 5 miles an hour the whole way through. You're going to see that savings, but it's really limited, like in terms of the total amount of minutes saved inside of the overall dwell is 3 minutes, which is about 20-ish%, 15 to 20%. So I think we talked about the ranges of Good to Go. So now flipping over to Wave to Go, you can see that Wave to Go has about 1.5 minutes. And that's ranging based on us utilizing a usage value of like, if 100% used Wave to Go. But that's also coupled with the enhancements we know are coming. So we feel like that 1.5 minutes is very, very stable in terms of estimating either through the enhanced version of Wave to Go, or if you presuppose that the option was no one could use anything else and just Wave to Go. So it gives you a pretty balanced approach on both sides. And then the last part of this bar chart here is interesting as well. As you can see, there's the alternatives from B all the way up to C. So 124 car dock all the way to 186. You don't see any change. And that is what we're calling this optimization is met. We've reached the line of which you can improve transaction processing to the maximum level. And what that actually is doing is it's balancing out the fact that the Issaquah class ferry is 124 cars and the dock is a minimum of 124 cars. And once you reach that optimization, now transaction processing isn't as important. And so now you're looking at the fact that all the cars that are necessary to fill one boat are on the dock. And there's still ancillary benefits from Good to Go in these dock sizes, but I just wanted to really highlight the fact that you kind of maximize this point of which when the boat and the dock match. Okay. Continuing on, sorry, I'm catching up here.
Hey, did you have a clarifying question?
Yeah, I did. I don't quite understand that, and I apologize. And if we want to hold that question till the end, that's fine, because you're, really trying to maybe get through the whole presentation, and there'll be room for questions at the end. But at some point, I'd like to just revisit that because I admit that, that like this, I really did try to look at stuff before the meeting, but I did not understand quite how the rest of the alternatives did not have, I did not understand what you just said. That did not make sense to me, but that could be just because I'm not a really good statistics person. And let me lower my hand before I forget. So if we want to revisit it at the end, that's fine. I just want to get that question out there.
Yeah, I think we can take a moment to just clarify that. It is pretty complex. So it sounds like your question, Penny, is around understanding this chart with the results here and specifically why the B alternatives and C are flat. Did I capture that? Okay. And Matt, do you want to take a minute to just clarify that?
Yeah, I'll do my best. Yeah, I think this is one of the discoveries of the model, right? So as we pump the model, 1,000 times through the system, these averages start developing, and what it really shows is that, and it effectively matches. It's the idea of you no longer have to chase a second batch of folks or customers through the toll booths to be able to load the boat. So the boat has a capacity of 124. If your dock, meaning everybody's past the toll booth that has been completed, that you no longer have that as a pinch point. And so now you just load accordingly. And in the most optimum way, when you don't have any of the transaction processing or cars trickling in, you just have operations taking over and loading the boat as efficiently as it can. The best they can do is they effectively make about a 4.5 minute gain against the baseline currently, against the 84 dock condition. So the 4.5 minutes doesn't matter if you have 150, 124, 155, or 186 in terms of capacity. As long as you have one boatload past the toll booths, you now can load accordingly in the most efficient way possible. Hopefully that helped a little bit.
Okay, so let me just make sure that I understood that. I think what you're saying is at some point having more cars on the dock or the loading lanes does not increase the efficiency because these methods are getting at what the pinch point was. And so just the real problem was the pinch point and not the size of the dock, which is why you're going with an alternative that pretty much keeps the same footprint. Did I get that right?
Well, let's see. We're commingling a couple things. So the recommendation. So the only recommendation we can make was within the A2 environment. So the A2 was the screening alternative. So what we did is associate a A2 with the good to go recommended option. If we're not recommending, you can apply good to go to any dock. It doesn't matter. What we're also showing in this graph is that you can't. You don't benefit from good to go and the transaction processing once the dock matches the capacity of the vessel. You just don't, you don't benefit from that. You don't need good to go. You don't need wave to go. You just need to be able to get all those cars onto the dock, and then transaction processing is taken out of the equation, so to speak. And it's one of the pinch points in the system. So that's kind of what we're saying. I am making sure that we're talking apples to apples. That's all.
Yeah, and I guess the other thing to clarify there, Penny, is like Hadley talked about at the beginning, we still have all of the alternatives on the table at this point. So we're walking through these last few meetings, different elements of screening, and good to go is one of those that will feed into the overall screening process before we make a decision about which options move forward.
Okay.
And we can talk about it more once I get through my little spiel here.
Yeah,
okay?
yeah. I don't want to delay this for too long. So, but
Yeah,
thanks for
I think
taking a moment to talk about that slide. There's a lot going on.
There's a lot
that's an
going
important
on.
question.
Yep, it was a good question. Okay, so kind of recapping now that we've kind of walked through the results and what those determined dwell times are for each one of the options against each one of the alternatives, we end up with, some general concerns, but then also some good positive takeaways. So really, when you look at the big scheme of things, it has minimal time savings. We don't significantly help on-time performance metrics. The on-time performance metrics, in terms of how even WSF is measured, is within a 10-minute threshold. So we're inside of that window in terms of being able to flip the script on-time performance. That being said, we do see progressively, better gains as we move to more complex options. And then as we just talked about, when the vessel matches the capacity on dock, you start kind of reaching kind of a maximum savings that you get in loading, in the loading time savings category. So those are the key things. And then as we move into evaluating the more high performing good to go options, 3 and 4 in this case, that also require, the toll booth attendants are not necessary in option 4, and then only half necessary in options 3. This starts looking at things because we can't apply certain discounts. So then when we can't do that, the first option was to take away vehicle passenger fares altogether. Okay, what does that do? So then the sample fares reflect about a 30% increase for vehicle drivers, vehicle and driver. And that's a big chunk of increase to absorb into a particular fare category. This increase is far outstretches anything that Ferries has ever put forth in terms of is a singular increase that would be needed. And this could burden people who are entirely dependent on the ferries, like I mentioned, living and working on Vashon Island. They're required to or they need this service. And so if you were to push that type of fare increase on them in one single blow, it could really affect how people live. So that's one part. That's how the fare increases were determined. And then as we move into the policy, what does it affect on the policy level? So there's 3 basic policies that we highlighted in the paper. The first being the Federal Transit Act. As I mentioned, WSF is a federally funded division, and therefore falls under some requirements that that create a need to provide discounts for age, if you're over 65, disabilities, and then also we have tribal agreements that provide waivers for passage on ferry. So these are key elements that need to be maintained no matter what, where they don't necessarily need to be maintained in the general good to go world, because there's always an alternative in the highway system. You can go around it and avoid tolling if you want to. In certain cases with ferries, you don't. And then on top of that, the way that the funding requirements land, we do need to provide these discounts, and that is very difficult for occupancy detection to do. They just aren't. The technology is not there to determine if someone is older or younger than 65 or younger than 18. So these things are difficult. The other 2 policy elements that WSF holds up is the HEAL Act. So that's the Healthy Environment for All Act, and then as well as the Title VI plan. So these protect against disproportionate impacts to historically underserved or overburdened communities. So these policies, when you intertwine them and you maintain the discounts, and then you also have this guiding post of how not to disproportionately affect populations, it combines into a challenge for options 3 and 4. Cost and schedule. So I think just in summary, cost and schedule, it follows suit with what I was saying before. Good to go options 3 and 4 cost between 14 and 17 million. That's their implementation go live price. Then you also, when you talk about options 3 and 4, it gets really murky in terms of how you would navigate the policy elements to this, and whether or not you could even overcome them. So there's a combination effect here that runs a lot of risk. That policy risk drives into the schedule risk, and so that then determines that if this project wants to be complete within the 27-29 window, there's a lot of risk of being able to do that with these particular options. All right, we finally got to it. This table is blinding, I understand, but there is I think it's a good summary of all the things that we looked at within the paper. It shows how the alternatives group together with the wave to go options, with the good to go options. Then it talks about the time savings for each one of them that was measured via the model. We did our costs, we stacked all those up. We did our timelines and our schedules, and we put those in. And then that second to last column is the vehicle queue length reduction over time. So that's that reduction rate I was talking about that shows the performance and how fast cars can move through and deteriorate the peak length of the queue. So it'll dissipate faster. And then last but not least is, do we have key policy considerations that are set there that need to be evaluated, that would need to be overcome, that would need to be navigated? And as you can see, options 1 and 2 do not. Options 3 and 4 do, as I mentioned. And then wave to go, the reason that's checked yes is mostly because of if there was some concert organization of implementing good to go and in parallel wave to go, we have to keep those in alignment. And so if you have something that's unique, that's at Fauntleroy, there's probably some policy in terms of fare structuring that we would have to analyze for wave to go to keep in alignment with that, but not necessarily be consistent with the rest of the network, the system as a whole. So just making a note of that. It's a totally different policy component, but just wanted to make sure that everybody understood where that yes was coming from. With that, I think we can move into the recommendations. This is what Dave started with at the beginning of the presentation. This is to recap what we're doing. We are recommending that we pair A2, alternative A2. So first of all, we would like to advance this good to go A2 option, and we would like to pair A2 with the good to go option 2. And the reason for that is that it's kind of the best balance of all the different elements. Gets the foot in the door for ferries with good to go. It best balances operational efficiency. It gives you about a 10% savings on a modeled level. Then it retains the current fare structure. It costs less and aligns with the project schedule. And doesn't adversely affect it. So WSF may consider fully automated tolling options, in the future. And so it's not taking stuff off the board. As I said, the options are very stair-step, the complexities can be built upon. And, but we need some technology to catch up to be able to adhere to some of these policy requirements and fare structure requirements. And then secondly to that, we also recommend that wave to go proceed through as alternative A3. And it provides a shorter, lower cost option, about a similar time savings, we think, once it's fully enhanced and modernized. And then the future funding is already in the process, and it's going to apply a new web store and a new app, like I mentioned. So all of those things are really good and are really going to help the usability for the customer, and which will in turn move people through the toll booths faster, which is the big game here. And then we can look to fully integrate wave to go once it's reached that platform level, that modernization, to match the modern value of what good to go is right now. And it makes it easier to connect the two systems. So that is all I have.
Okay, thanks, Matt. Dave, did you just want to kind of cover this slide with the alternatives and talk a little bit about how this comes together to the full picture of alternatives?
Yeah, I wanted to add another comment to what Penny was asking, which was in all of this, and Matt's done a great job here trying to explain it. In all of this, it's important to understand kind of the impetus for this effort, which was, can we build a same size facility that we have out there today and use good to go to help us with the processing times? And that was the purpose of this effort. And what we learned is you can save a little bit of time with options 1 and 2. You can save more time with options 3 and 4, but we have some real challenges both with our fares and our policies that Matt hit on for implementing the sort of the more robust good to go options. So these all continue to be options or alternatives, that we will take into the level 3 screening. Matt hit on A2 and A3 will be advanced, but again, the A2 option will be advanced only with that option 2 good to go. We will not advance A2 with the option 3 or option 4 good to go. So the realization for time savings is less than maybe what folks had hoped, but all of these will continue to move into that level 3 screening.
Steve. Okay, I think with that, we can open it up to any questions, feedback from you all, anything that you'd like Matt to clarify or Watsi on what we've shared.
We're spending.
I'll lower my hand, but if anyone else also wants to go, I mean, I just ask questions, but that one slide, I think it was Hadley who sent out the presentation. I finally found it because I was looking under the Fauntleroy thing, and it was that slide that you showed at the end with the summary results that kind of threw me with the conclusion, the bars. You're like, here it is, the summary of everything right there. And I'm like, yeah, that's the one. And I didn't understand it because that one. I didn't understand it, how the conclusion worked with that, because they all looked kind of the same. So does that make sense? I'm like, the time savings is actually more for the other alternatives, and the cost seems the same. The time in months, the vehicle queue I was like, so, but then Dave said something about fares and policy considerations. And I'm like, wondering if that was where that was a tipping point for the conclusions and not so much the time savings.
Yes, exactly.
Okay, because I was, but that doesn't make
That was a great
sense.
summary, Penny.
Yeah, Penny, I think the other thing that's worth noting here is, Matt, maybe you could speak a little bit to the difference. So when you look at the B and C alternatives and you see that 4.5 minutes of time savings, kind of where is that time savings coming from versus the time savings that you're seeing with the alternatives? A.
Yeah. So first and foremost, it was not entirely based on minutes saved. So that is 100% true. And then in terms of the recommendations, in terms of how you read this summary of results, yes, what you see in the bigger docs that we talked about, the good to go gets washed out. Wave to go gets washed out. The ability and the speed of which they are processed has no effect on the benefit of that doc. So that once you process, however you process those cars coming through the toll booth, it really, as long as you get all of those cars on the other side and they're waiting to be loaded there, and you have the capacity for it, it really, you don't see the benefits with good to go. Now, I did say this last night, I'll say it again, in terms of our approach here. There are fringe benefits of good to go. I used the Mariners game last night. So if you have a bunch of people racing down the hill to try to get on the boat last minute, that good to go transaction processing, that ability, the horsepower to be able to get cars through faster, just gives those last minute arrivals just that much more of a chance of making the boat, and the boat still leaving on time. So there are some benefits within the larger dock sizes, but they're not, the transaction processing time does not govern the minutes anymore, the minutes saved.
And Matt, would it also be fair to say that option 3 and 4, their cost is much higher the timeline is much higher. And that was some of the other key considerations, is the urgency to preserve and replace the Fauntleroy dock.
Mhm.
Doesn't
Yeah, that's a
fit
great
to have
point.
44 and 52 months to just implement Good to Go when we need to move forward with this project. It doesn't mean that there wouldn't be any benefit of options 3 and 4 to WSF in general or other routes in the future, but in terms of making a decision on which alternative to move forward for this
Yeah,
particular project.
Yep. And I probably should have summarized it a little easier. Like options 1 is, option 3 is double the cost of option 1. Option 2, option 4 is double the cost of option 2, or almost 2.5 times option 1. So you have some significant increases in terms of development. I know in terms of what the overall costs to be able to implement these technologies are. So
really, Penny, it came down to kind of cost benefit, and the policy considerations are real. The estimate is 30% fare increases, for example, and that impact on the community, when coupled with the, minute or so difference in time saved, just didn't seem something worth pursuing. We generally hear a lot of concern from ferry customers, even when we propose a 2 to 4% fare increase, and 30% would really be burdensome to a ferry dependent community for the minimal time savings that don't even fall within our on-time performance metric, which is 10 minutes.
Okay.
Does that make sense?
I think so. I'm not saying I really fully understand it. I think Matt's point is I can really sense how that is a really key piece of it. And then also the fact that you have these other factors that came into it. And that's just something that I'm going to have to just maybe accept that I don't fully understand how that all works with, because I just don't even use Good to Go or Wave to Go, and I don't use Ferry. So, but I at least wanted to throw that out there for further discussion, because I found this table to be somewhat confusing with the conclusions when the information across the board looked almost identical between different alternatives.
This is
Yep,
really helpful feedback.
Yeah. Agreed.
I don't know if anyone else found it confusing, but but I actually took the time to read through your slides, Haley. So
If you're really interested, there's 86 pages, Penny. You can dive in all you want.
right, because that's just going to really help me become the better statistician, to understand how these numbers are crunched. But no, I really appreciated that you guys sent something ahead of time. I always wish I could say I just looked at it every single time and poured over it, but I do appreciate you taking the time to answer my questions.
Yeah, absolutely.
Thank you. Are there questions for Matt? Yeah, well, you do all have a copy of the Good to Go study in your inboxes and in the chat here today, and we know where to find Matt and the rest of the WSF team if you have any further questions after the meeting, or you want to talk further about any of this. I know we have, Dave, a couple of other slides that we can move along and share an update on what's going on at the intersection.
Yeah, let's do that, Laura. This was the other, a couple more things we want to share with you all before we adjourn. As many of you are aware of the intersection at Fauntleroy in the dock, and there's been, I think probably some of you have witnessed or been out there when there's either been near misses or actual accidents that have occurred with vehicles in that intersection. You're probably also aware we have off-duty police officers on an occasion that are out there helping to handle traffic that's coming off the dock when we have those searches of emptying vehicles. So this work is something that we have been talking about at length at Ferries for many years, and this project has the opportunity to take action and correct really what we consider an unsafe situation for travelers, both in vehicles and walking or riding a bike. So we've started the effort to get Jacobs under contract to start the design work for this. We've been meeting with SDOT and King County on the approach to signalizing this intersection. We've kind of walked the community through what we're trying to do at this location as well. And I just wanted to give you a little bit of an update on this. We do have some survey work that we're going to start in September. There's also some geotechnical work that's going to happen later this fall. And then with the overall goal that we would have a signalized intersection in place by, kind of essentially fall of next year. So we've got about a year to design that and get contracts out on the street and hopefully have a contractor on board. And so when the season starts to slow down a little bit, the traffic lightens up a little bit, we'll be out there installing a couple of signals. There will still be a lot of involvement between the state and the city on signal timing and making sure that we have the appropriate amount of green time and red time for both vehicles and for pedestrians. But we're excited to kind of get this project going, and we're sort of treating it as a separate project from the overall program. It is critical that it be signalized, I think, before we actually start the larger program. So that's why we're getting on it now. So, and I could take any questions that folks have on that, but I did want to make sure that Charlie had an opportunity to update, in addition to the intersection work, some real estate related work. So Charlie, do you want to give your update?
Sure. Can you hear me?
Yes.
Adjacent to, on the north side of the Trestle, there's a King County lift station, and just north of that is I call it a white house, small one-story house with, I guess, a little basement on the water side of the building. We've been talking to King County about procuring it, and just wanted to give you an update on that transaction. So we did have some of our team members from WashDOT's real estate group go and meet with the tenants and let them know that we're considering procuring it from King County, and answer some of their questions and told them what next steps would be. And then currently we're taking having an environmental assessment of the property, and that's in advance of appraising the value of the house. So that's where we are today, and we can next time we meet, we'll give you an update on where we're going. But the goal is to use that house as a staging area and office space when we have the two construction projects, the intersection project and the larger trestle replacement project. That's all I have. Yeah.
Thanks, Charlie. Any questions for Charlie about that work or the intersection? I think that we can go ahead and pull up our next steps. So we have a couple of upcoming topics for this group, including our cost estimates and approach to constructing the terminal before we get to the level 3 screening, and we identify an alternative to move forward into the next phase of environmental review. I think that's all we have planned. Dave, Hadley, any other final words?
Well, I'll just say appreciate everybody being here today and taking some time out of your busy weeks. I hope everybody has a great holiday weekend. This is really important work for us. We've been at it for a long time, and you can hear the passion in Matt's voice as he talks about this. Really want to make sure we kind of look under every rock and look for every operational strategy that might be effective at making this the best operating facility it can be. So I appreciate everybody's input. And if you guys do have anything else that comes up, or any questions that you have for myself or for Matt or Hadley, drop us a line. We'll be happy to answer those offline. And again, thank you for being here today.
Thanks, everyone.
Thank you.
Good. See you.